we are going into Mohs circle now. Okay, we're going to construct Mohs circle, right? So later on, I'll tell you why Mohs circle. So we are going to label this as your point X, and this is your point Z. Okay, I'm going to stop here for a bit, and if you have any questions, can you ask me now? Thank you.
Yeah, I've got a question.
Okay.
So how did you figure out the direction of the shear force on XZ and ZX for element A with the forces that were given on the I-beam?
Okay, don't worry about that first. I will teach that on, as I said, this is just an introduction. I will teach that in the shearing stress in beam and thin wall. Okay, so don't worry about that first. Okay.
Okay, thank you.
I'm glad that you are observing that. Okay, I'm glad that you are observing that. Hey, how do you determine that? Okay. Any other questions, please? No. Okay. So now, given the Mohs circle now, so we know how does stress X and stress Z come about now. Okay. So now we are going to go into Mohs circle. So I'm going to just roughly sketch Mohs circle. So we say that stress X is in compressive, stress Z is in tensile. So I'm going to go into Mohs circle. So you will learn Mohs circle, okay? You will learn Mohs circle in 2D, more critically in 3D. Okay, as I said, we are designing the real stuff now. Okay, so 2D is just to know the basic working principle. 3D is actually design work. Okay, by our teachable. So on Mohs circle, like some of you can recap, we have two axes, right? So this axis is our normal stress, and then we have our shearing stress. Okay, so this is our shearing stress. So shearing stress over here, you have element rotate clockwise. Down here, you have element rotate anti-clockwise. So we knew that for this case, it's just an example. We saw that stress X, Z is in tensile. Okay, so it's in tensile over here. So this is your stress Z magnitude. And then you have your stress X. For this example, we realize that stress X is in compression. So this is our stress X. And we calculate our shear. So the shear will be down here. Okay, so this is our shear. And then you will, from here, we can locate it where is our point X and where is our point Z. So if you look at point X, is on your X line. Okay, and if you look at this rotation, this arrow over here, the rotation is going anti-clockwise. So this is anti-clockwise on stress X. So this is your X point. Again, don't worry about this. I'll teach you all more detail. Okay, this is just a preview. So on point Z is in tension. So it's this point, that this line that we're going to focus on. So this arrow over here that you can see is inducing an element rotation that is in the clockwise direction. So we are very sure that this is your point Z now. Okay, then you draw a straight line. Okay, then you draw a straight line. Okay, so from here we can construct Mohs circle now. Okay, we can construct Mohs circle. I'm just going to briefly sketch a Mohs circle because I don't have a compass with me. Okay, so I'm just going to sketch our Mohs circle. 1.6. As I said, this is just a sketch. Okay. My computer is slowing down and it's new. Hold on, it's still thinking. It is still thinking this stupid thing. Okay, stop thinking. Very good. So this is your, I'm eyeballing this, okay? Yeah, I do not get it to work. Crap. It's like moreover, you know, not more circle anymore. Oh, I think I know why. Sorry, I will not waste your time. Okay. So 1, 2, 3. So this is just eyeballing. Okay, I know I should not eyeball. Right, it's not a bad eyeball. Okay, but I have deficiency. You know, everything has to be done properly. Right. Okay. Sorry to make you wait. So what you can see now, this is your mole circle. And what I want to catch your attention is this. I want to catch your attention this point. So those 2 points are known as your stress 1 and stress 2. Okay. And stress 1 and stress 2 position is depending on the normal stress and shear stress of point X and normal stress and shear stress of point Z. So if you look at the coordinates over here, so this is dependent on your stress Z and it's dependent on your shear ZX or shear XZ, does not matter. So on the other one, this is the point X is controlled by your stress in the X direction and your shear XZ. Okay. So these 2 points control the position of stress 1 and stress 2. Okay. So if I were to draw another line down here, right? I draw another line down here. This value over here is your average stress. Okay. This value over there is your average stress. So you can see from here, right? Now, can anyone tell me, right? What do you realize about stress 1 and stress 2? Anyone? It went silent.
Stress 1 is greater than stress 2.
Okay, stress 1 is greater than stress 2. That's absolutely right. So we realize that stress 1, okay, we realize that stress 1 is greater than stress 2. Anything else? Anyone? So this is our 0 point. No? Okay, so stress 1 and stress 2 are known as the principal stresses. Okay, so these are known as your principal stresses. Principal stresses means what? The shear is equal to what? 0. Okay, now you have a shearing stress that is equal to 0 now. Okay, now if we go back to our test, okay, so this is how we calculate stress 1 and stress 2. And stress 1 and the principal stress, the principal stresses position are dependent on your stress or on your stress X, stress Z, and your shear XZ, right? So these 3 stress magnitude are under the load of what? Of bending moment, exerting, and under what? Shearing stress. And we could somehow normalize them in our principal plane or our principal stresses such that the shear stress is equal to 0. So from here, right, from here, if we go back to the previous slide now, okay, if we were to look at over here now, okay, or I'll draw it. So under sorry to scroll so much. So under uni Excel, I put it under uni Excel tensor test. So we have a we have a structure. We put by P, and then we have an element down here. Okay, I put an element down here, and then based on this, our element, right? If we will draw a bigger element, so this element only has our stress X value. Okay, based on the unit tensile test. So if we go back to construct mole circle for our unit XL test, okay, so I go back to our mole circle view. Okay, so let's say we test. So I'm going to follow the scale that we have used in our previous mole circle. Oh, I'm so excited about this. I don't know about you. I'm so excited. I'm so high now. Unbelievable. Some of you say, yeah, Eugene, you're on drugs today. Oh, sorry about the background. My daughter is crying, okay? Yeah, there you go. It's not easy for us. Daycare is closed, but we have to work as normal. So likewise for you guys, okay? Online course is not easy for you guys to learn. I understand that. Now, coming back to here. That's why the quiz are 30%. So you have a shear, right? So I will call this point X, and I'll call this also a point Z, right? So for this case, we realize, so this is unit XL tensile test. So this is to acquire, okay, acquire mechanical properties. Okay, you did this to acquire what? Mechanical properties. Okay, so from here, you did a test. So again, we plot we are on mole circle again. So we come to this value. So this is our stress X. Oh wait, the computer is not behaving. So this is our stress X. Over here, this is our stress Z because there's no stresses on Z. And then this is our X point. And this is our Z point. Then from here, we can construct a mole circle. Okay, we can construct a mole circle. So this is our mole circle. Okay, further a bit. So this is our mole circle. Okay, and this is based on our mechanical loading. Okay, so this is based on mechanical loading, mechanical test. Okay. Okay, so we did a test under unit Excel, and we see our stress X over here. So I'm going to call this our stress what? Allowable. And this stress allowable that you can see over here, right? Also define that the shear is also equal to what? 0. Okay. So now I'm going to impose this value into what we have found earlier. Okay, so I'm going to impose this value. So I'm going to impose that this is our, I'm going to draw in red. This is our stress X line. This is what we found. Okay, so this is our stress allowable. Okay, so what does this mean based on normal stress? What